Inside the pipe, number 5, continuation of the studies. Many of the books and publications in corrosion of pipelines mention equivalent circuits to justify theories, but when these are actually created, they do not work. I have always based my scientific beliefs from personal observations, and therefore when I reread equivalent circuit, I used electronic components to create these suggestions. You can see the results in the pictures I publish, and I use available instruments to make and record the results. I photograph the instrument reading to enable students to carry out their own experiments and form their own hypotheses and theories. You will see that I have used a half cell made of copper wire in a plastic tube filled with a saturated solution of copper sulphate, and that contact with the electrolyte is through a porous plug. This is held in place by an electronic construction tool with which you are probably familiar. 2 connected metal trays are used to contain the electrolyte and the buried pipelines in this part of these experiments. The following is pictures and comments about equivalent circuits that I have made to investigate such claims. Equivalent pipe to soil measurements. Picture 44 is the first in the series of equivalent pipe to soil potential measurements that show that this is a voltage measurement between 2 variable potentials, and that the copper sulphate electrode cannot be used as a reference potential in the way advocated by NACE and ICOR. The meter in this picture is displaying 560.7 millivolts, with the probe positioned on the damp cloth beside the pipe and the common of the meter connected to the pipe metal. Picture 45. In picture 45 we can see the measurement of 578.3 millivolts, and that the wiring has not been changed, only the position of the probe. This picture alone proves that we cannot use a copper sulphate electrode as advised by NACE and ICOR as a reference potential in equations that require the value of E denoting the potential energy at a node. Picture 46. In picture 46 you can see the measurement of 593.9 millivolts, and that the wiring has not been changed, only the position of the probe. This picture confirms that we cannot use the copper sulphate electrode as advised by NACE and ICOR and others. Picture 47, you can see the measurement of 589.5 millivolts, and that the wiring has not been changed. And this picture proves again that moving the probe changes the voltage. Picture 48, you can see the measurement of 628 millivolts, and that the wiring has not been changed, only the position of the probe. The probe is exactly over the far coating fault and subject to the EMF of the corrosion reaction at this location. This again proves that it's the position of the probe and not the wiring that has changed. Picture 49 is the same. It's different reading, different position of the probe in the electrolyte, 562.6 millivolts. Picture 50 gives a clear view of the measurement and 573.3 millivolts. Again, this illustrates that moving the probe on the soil changes the reading that we get. These pictures prove that it is possible to make repeated observations as required by the scientific method. This picture again confirms that we cannot use the copper sulphate electrode as a reference potential. In picture 52 you can see that the measurement of 552.8 millivolts is due to the position of the probe over the nearest coating fault. In order to properly study this section, you must join our Patreon, in which case you can ask questions, add your comments, add your own evidence to the study that you are then involved in. If you are just following through YouTube, then it would help everybody if you subscribe and put the thumbs up, like this particular video. This helps because the algorithm picks up the number of views, and that helps to get cash flow through the whole of the Cathodic Protection Network blockchain, which ensures a fair distribution of any of the profits from the results of our joint work. Thank you very much for listening to this, and you can ask questions and add comments at the bottom of this video, and you can see the accompanied HTML document which I've prepared together. Thank you very much for your attention, and see you in the next video.